operations with scientific notation. Okay? So basically what you're going to do, they want us to multiply these numbers. 4 million and 20 million. Okay? And when you got large numbers like this, it's best to put it in scientific notation first and then do the problems. So for example, this would become what? It would become 4 times 10 to the
6.
right now I want the decimal to be here after the 4. So 1, 2, 3, 4, 5, 6 times 10 to the 6. Okay? So that is correct. And now let's do this one. 20,000 or 20 million. Okay? You want the decimal to be after your first non-zero number. So it would be 2 point or 4 point, which at the end of a number you don't have to have it, times, and then 1, 2, 3, 4, 5, 6, 7. Okay. So now that we have it like this, hopefully you remember that you can multiply the numbers. 4 times 2 is 8, and then you just write 8 times 10 to the, and then remember when you're multiplying exponents, you actually add them. So 6 plus 7 would be 13. Final answer as a scientific number, scientific notation, is 8 times 10 to the 13th power. That would look like that, and then that would be 1,000, million, billion, trillion. 80 trillion, and that is 80 trillion written as scientific notation. Okay, so it's kind of teaching you how to do that. So now let's look at some harder problems and see what you can do. Write the numbers 0.003 times 10 to the negative 4th and 2 times 10 to the 20th power. They want us to write this in scientific notation and then multiply. Okay? It kind of is in scientific notation. So why did they say write this in scientific notation and then multiply? Well, this one is written correctly.
It's not after the first non-zero number.
This decimal is supposed to be after the first non-zero number. Very good. So I want to show you what this looks like. So I'm going to bring this down, 0.003. What does it need to have right here for it to be, and right here for it to be correct? Okay? So if it's 0.003 times 10 to the 4th power, that times 10 to the negative 4th power means that from my decimal, I'm going to go negative, which is left, 4 more times. 1, 2, 3, 4. Now stay with me, okay? So this is the answer in standard form. So I took this scientific notation that was written incorrectly and made it a standard number. So all I did is took this number and then multiplied it by that, which made it go left negative 4 more, right? So this is my new number, okay? But where is the decimal supposed to go?
After the first.
After the first non-zero number. It's supposed to go there. So watch what happens. 1, 2, 3. So I have 3 times 10, and as you can see, it's not just 4, it's 1, 2, 3, 4, 5, 6, 7 negative because you're going to the left. So this 3 times 10 to the negative 7 is now written properly. So I'm going to go up here and write 3 times 10 to the negative 7. And now that we have that set up right, now we can do scientific notation by adding and multiplying and all that. So here we go. You take your numbers and you multiply them. 3 times 2 is 6 times 10. And then remember, when you're multiplying exponents, you're actually adding them. So negative 7 plus 20 would give me 13, right? So that would be 13 positive. Am I right? Yes. 6 times 10 to the 13th power. Got it? All right, let's do a few more that are harder, and then we're going to move into not just multiplying scientific notation, but also dividing it. Okay? So here's our last one on multiplication to make sure you're paying attention. So here's what it says. Multiply, and then it gives me 2 problems within a parentheses. So Okay, that's one of the problems, and then the next two is they put it like this. Okay, so this is the problem. It says multiply. You see this? It says multiply. Okay, we're going to write them in scientific notation and then multiply. Okay, this one looks like it's in scientific notation, but it's not. Why?
Because it's not after the first non-zero.
Right, very good. So what we're going to do is we're going to take this number, 1, 2, 3, 4, 4, times 10 to the negative fifth. My decimal is here, and they're wanting me to times it by 10 to the negative fifth, which means I need to go negative 5 more to the left. Negative means left. 1, 2, 3, 4, 5. Okay, so now this is my new number that I'm trying to put into scientific notation. So 4 times 10, because I want my decimal here. So how far is it away from this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I went to the left, negative 10.
Yep.
So this answer becomes 4 times 10 to the negative 10. And I'm multiplying that by, and these ones are a little bit easier. So this 700,000, I'm supposed to have a decimal here. Right now it's here at the end of a number, even if you can't see it. So how many times did it go past? 1, 2, 3, 4, 5. And I'm going to the right. So this becomes 7 times 10 to the positive fifth. Because there are 1, 2, 3, 4, 5 right there. And it's supposed to be here. You get it? Usually if you see numbers or zeros after a number, it's going to be a positive. If you see zeros in front, it's going to be a negative. Just so you know. Okay, so now what are we going to do? We are going to multiply the numbers. 7 times 4 is 28. Times 10. And then negative 10 times the exponent 5. Negative 10 exponent times 5 exponent is actually, you're adding them. So negative 10 plus 5 would become negative 5. So negative 5. Now, you would think I'm done. I answered it, but guess what? There's a problem. Look right here. 28, the decimal's right here even though you can't see it. Where is it supposed to be?
Read it after 2.
Okay, so watch what I do. I'm actually going to write this 28 into a standard number. 28 times 10 to the negative fifth means right now it's here, and it wants me to go negative 5. 1, 2, 3, 4, 5. Fill in with zeros. Okay, but where do I want it to be? I want it to be here, so guess what happens? Look. I want it to be here, 2.8, and it's only 1, 2, 3, 4. Okay, so times 10 to the negative fourth. See that? So this is sort of the answer, but this is the final answer because we always want the decimal right after the first non-zero number. Okay? Like you got it?
Yep.
Alright, now we're moving into division of scientific numbers. Okay, pause that for a second. Alright, we're going to continue in this lesson, and the next portion is on division. And so, for example, let's say you had 20 million divided by 4 million. Okay? Now, let me show you how this would look. Let's write this as a scientific notation. This would be 2 point, or the decimal's at the end even if you can't see it, times 10. If the decimal's here, then it's 1, 2, 3, 4, 5, 6, 7. Times 10 to the 7th. Divided by, and this would be 4 times 10, and there's 1, 2, 3, 4, 5, 6. Okay? Now, once we get to this point, it's similar to the multiplication of them, but this time it's division, okay? And so I'm dividing the numbers, 2 divided by 4, which hopefully you can see is a half. So that's going to give you 0.5 as a decimal number. Half, 2/4 is reduced to a half, and half written as a decimal is 0.5. Hopefully you know that. Okay? And then times 10, and then just like when we were multiplying, you add exponents. When you are dividing, you subtract. So I always take this 7, or the number that's up here, and put minus that one. sometimes you'll have a negative number here, and so it's important that you write it out. So 7 minus 6 would be 1. Okay? Now, stay for me with just a second. Let's say this said negative 6. Okay? So then I would go 7 minus a negative 6. So this would become plus, and then you change the opposite sign. So it would be 7 plus positive 6, which would give us 13. Okay? That's if this was a negative, but it's not. So I just wanted you to see that. Now, we've somewhat got an answer, but that's not the final answer because the decimal is supposed to be after the first non-zero number. So let's stay with me for just a minute. 0.5 times 10 to the first power would mean that I would move it times 10 to the first power 1 spot to the right. Okay? So this would become 5. Okay? Now, 5, and then there is no moving to the right or left, that's just it. So the final answer is just 5. 5 period, 5 decimal, or you can just leave it as 5. Okay? Now, let's do another one. And this one, they're going to be negative numbers. Numbers that are written actually like tenths, so like tenth, 100,000, 10,000ths, 10,000ths. So, for example, look, 0.0016. So this is tenths, hundredths, thousandths, 10,000ths. So you would say this is 16 10,000ths with the THS at the end. They want us to divide this by 400,000. Okay, now remember, the very first thing you want to do is make these both into scientific notation. So, this is my standard number, okay, and I want my decimal to be here. Okay, so it's going to be 1.6 times 10, and since it's to the left, 1, 2, 3, and I'm going to the left 3 times, so it's a negative 3. Let's check that to see if we're right. 1.6, and then I go to the left 3 times, 1, 2, 3. So I would have 0.0016, 0.0016. Okay, very good. So that means I did it right. All right, so that would be my top one, and now let's do the bottom one. It would be 4 times, and then 1, 2, 3, 4, 5 times 10 to the 5th. Okay, and if I check that one out, then it would be 1, 2, 3, 4, 5. And it's 400,000. Yes, we're correct. So I have the correct written the way it's supposed to be. So now what you do is you take your numbers and you say 1.6 divided by 4. So that's exactly what you would do. 1.6 divided by 4. And I would end up getting 0.4, it looks like. Yep. Okay, so this answer would be 0.4. But I'm not done. So times 10, and then negative 3 minus 5. Remember, you subtract these, the top minus the bottom. So negative 3 minus 5, I'm going to make this a plus negative, so it becomes a negative 8. Okay? Alright, now, this may look like it's correct, but remember the decimal is supposed to be after the first non-zero number. So I'm going to want to make this into a standard number real quick. 0.4 times 10 to the negative 8. Let me want to put 0.4 right here. Times 10 to the negative 8. So I'm going to go negative 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And that would what it would look like as a number. But I want it to be here. I want my decimal to be after that first non-zero number. So this is 8 plus 1 more makes 9. So this 0.4 becomes 4 point, which you don't have to have a point because the point's there even if you can't see it, times 10. Instead of it being negative 8 spots, we went negative 9 spots, okay? And I can take this and check it out, 4 point, and then go negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And as you can see, we are exactly right. Okay? So it's always helpful. This would be the final answer. This one almost was correct, except that the decimal wasn't after it. So then when we moved it, okay? I would always recommend writing it out like this. A lot of times people go, oh, I'm just supposed to move it 1 spot. Then that's 7, negative 7 or negative 9. You need to check it to make sure. All right? All right. now let's do multiplication and division problems. So stay with me. All right, multiplication and division. And for example, here's one of the problems. 0.0007 times 10 to the negative 23rd. And they're wanting to multiply that by 4,000 times 10 to the 16th. Okay, down to the 6th. Okay, and then you're going to divide all of that by try to make them all into scientific notations, and then once you get it into that, then we are going to take the numbers and multiply them, take the numbers and multiply them, and then the final step would be divide. So let's do this, okay? Let's take this, and I'm going to bring it down here for just a minute. 0.0007, if you want to put a point or 0 in front, that's fine. Okay, now, times 10 to the negative 23, that means that I'm going to go negative to the left 23 more times. So stay with me. Let's pretend 1, 2, 3, 4, and we kept going 23 times. Okay, and I'd fill in with zeros all the way. Okay, if this is negative 23 from this spot to here, where do I want my decimal to be? I want it to be after the first non-zero number. So if this is negative 23, then this is 1, 2, 3, 4 more. So 4 more of the and I'm going to the left, so 1, 2, 3, 4, negative 4. So negative 4 more would become negative 27. So this would be 7 times 10 to the negative 27th power. Okay? Hopefully you can see that. All right? Let's do the next one. This one. This one is 4,000 times 10 to the 6th. Okay, so right now, where's the decimal, even if you can't see it, at the end? And I'm going to go 6 more. 1, 2, 3, 4, 5, 6. Fill in with zeros. Okay? But where do I want my decimal? Right there. So that's 1, 2, 3, and then 6 more. 6 and 3 make 9. So 4 point is the same thing, times 10. And this is 6 plus 3 more makes 9. So 4 times 10 to the 9. Okay? So now, those are our top two. Alright, let's go on and make these into scientific notations. So this 0.00004, written as scientific notation, it's already in standard numbers. So 4, I want it to be here. 4 times 10, and this is 1, 2, 3, 4, 5, and I'm going to the left, so it's negative 5. Okay, so negative 1, 2, 3, 4, 5. 4 times 10 to the negative 5th. Okay, that's what that is. That answer is. All right, and then let's do this 7 times 10 to the 6th. 7. Okay, and it already is in scientific notation. We don't have to do anything to this one because the decimal is after, even though you can't see it, the first non-zero number, and it's already written in scientific. So we got that one right. So what I'm going to show you, I'm going to go and bring this down, okay, because I'm going to erase all this. Because these are our new numbers, okay? I'm going to put those back in parentheses because we're going to do something with them. Because I'm supposed to multiply this times this. So now I'm going to multiply this times this. So stay with me. I'm going to move down here to work it. So now remember, you multiply the numbers. 7 times 4 is 28 times 10. And we are multiplying the exponents. And when you multiply exponents, you're actually adding them. So negative 27 plus 9, which ends up being what? Let's see. Negative 18. Yep. Negative 18. Okay. Now, we've sort of answered that completely. Right now, the decimal is after the second non-zero, even though you can't see it. And it needs to be here. So let's pretend for just a minute. Let's say there's the decimal right there. And I was going to go negative 18. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to 18. And instead of doing it negative 18 times, I'm going to take my decimal that's at the end and I'm going to move it to the first non-zero after the first non-zero number. So what did I do? I took 1 away. So instead of it being negative 18, this is going to be 17. And then this 28 becomes 2.8. Hopefully that makes sense. So this is my answer to this top problem. 2.8 times 10 to the negative 17. Okay? Now, let's do the next one. Okay? Again, 4 times 7. Let me go ahead and put this over. Okay? So now 7 times 4 is 28 times 10. And then, remember, you're going to multiply, which really means you're going to add the exponents. So this is negative 5 plus 6. So it's to the 1 power. Okay? Now again, we're not completely right because the decimal is not after the first non-zero. It's right here. So this would be 28 point. And then when I multiply by 10 to the 1, that means I moved it 1 time. Okay? So it's 280 as an answer, as a standard number. But I'm wanting to be here. So that becomes 2.8 times 10 to the 2. Got it? Okay? Now, we are doing really well, okay, because we've multiplied that times that, and then we multiplied this times this. Now we are going to divide. So, what is 2.8 divided by 2.8? Hopefully you see that that's 1 whole. Anything, the same number over the same number, 5 over 5 will become 1 whole. And then this 10 to the negative 17 and the positive 2, remember you're going to subtract these. So this is negative 17 minus 2. So that becomes a plus negative. So negative 17 plus a negative 2 makes a negative 19. Okay? Final answer, 1 times 10 to the negative 19. Okay? And that's how you would perform that. I'm going to do one more of these to make sure you're understanding it. I would recommend watching it because make sure you're understanding it very well. Okay? Last one. Here we go. 20 times 10 to the negative 45. Okay? And then 400 times 10 to the 20th power. All over 100,000 times 0.0008 times 10 to the negative 15. Okay, let's again, one at a time, put it in proper scientific form, and then we will then multiply, and then we will divide. Okay, so let's take it step by step. If this is 10 or 20 times 10 to the negative 45, that's 20, and right now the decimal's here even though you can't see it. And let's pretend I go to the left negative 45 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 45 times. I went to the left negative 45 times. Where do I want my decimal? Right now it's at the end. I want it here. So I took away 1. So instead of going 45 over, I took away 1 of them. So it's going to be negative 44. So for this answer, it's going to be 2 times 10 to the negative 44 power. Done with that. Okay? And now I'm going to multiply it by this one. Okay, so let's take 400 times 10 to the 20th power. Okay, so this, for example, right now the decimal's here, even if you can't see it. And they're wanting me to multiply that 10 to the 20th. That means I'm going 20 times this way. Okay, but I want my decimal here, so that's going to be 20, 1, 2. So I'm going to go 1, 2, and then 20 more times, which makes 20 plus 2. So this would be 4 times 10 to the 22nd power. Okay? Hopefully you understand that. Okay? I'm done with that one. And now that's all over. And now let's do this one. 100,000. Now this is just a standard number, and they're wanting me to write it in scientific notation. Right now the decimal's here, even if you can't see it. But I want it here. Okay, so that means it is 1, 2, 3, 4, 5 past where I want it to be. So this one would be written 1 times 10, and then there's 5 after it, to the 5th power. And I can always check it and go 1, and then times 10 to the 5th power would mean 1, 2, 3, 4, 5, excuse me. And when I put that in, it's 100,000, so I got it right. Therefore, I know that I did it right, okay? Alright, and then this last one. Looks like it's in somewhat scientific form, but it's not proper because this decimal's here instead of here. So, let's write this down right here. Okay. Times 10 to the negative 15, okay? Here's the decimal. Let's go and make it into a standard number. This is in scientific notation form, so we're going to put it as a standard number. And I'm supposed to go to the left negative 15 times. So, negative 1, 2, 3, 4, 5, 6, 7, 15 times. So I went negative 15 times. But, where do I want my decimal? Here. So, 1, 2, 3, 4 more going to the left, so negative 4 more. And so negative 15 plus negative 4 more would give me a negative 19. So, this would be written 8 times 10 to the negative 19th power. Okay? And that becomes our new problem. Okay? With all scientific notations. Okay, so then your next step is to multiply this times this, and then we're going to multiply this times this, and then we're going to divide those two. Okay, so here we go. 2 times 4 is 8 times 10. And remember, we're multiplying, so this is negative 44 plus 22, and that's going to give me a negative 22 answer. Okay, done with that one. All over. Now here we go. 1 times 8 is 8 times 10. And we're still multiplying, so that means you're adding these. So this is 5 plus a negative 19, which would become a negative 14. Okay, done with that. Now we're going to divide. You divide your numbers first. 8 divided by 8 is 1 whole. And then times 10. And then this negative 22 minus the negative 14. So this negative 22 minus negative 14. Remember, you subtract the exponents when you're dividing. So negative 22, and I'm going to change this minus sign to a plus. And when I do that, I change the sign to the right. So this is negative 22 plus a positive 14. So, let's see, 14, that's going to give me 8, negative 8. Okay? Because I want to take the sign of the biggest number. Alright? And so 8, negative 8 would be that answer. So, final answer is 1 times 10 to the negative 8th power. And that is lesson 8.